and welcome to today's ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. I'm Michelle Craig, a teaching stream professor in the Department of Computer Science at the University of Toronto, where I regularly teach thousands of undergraduate students. I'm also one of the inaugural editors-in-chief for ACM Engage CS EDU, a peer-reviewed collection of open access teaching materials. I chair the steering committee for the ACM SIGSE Technical Symposium, and I serve on the ACM Education Board. For those of you who may be unfamiliar with ACM or what it has to offer, here is more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. You can see some of these highlights on your screen. ACM provides access to the ACM Digital Library, the world's most comprehensive database of computing literature, leading publications and global conferences that draw top experts on a broad spectrum of computing topics, support for education and research, including curriculum development, teacher training, the ACM Turing and ACM Prize in Computing Awards, and the ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. Before we get started, we'd like to quickly mention a few housekeeping items shown on the slide in front of you. If you have questions at any time, please type them in using Zoom's Q&A button. We'll organize the questions as Dan and Leo speak and try to get to as many as possible. This session is being recorded and will be archived. You'll receive an email notification when it becomes available. Please check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it out to help us improve our tech talks. So today's presentation is LLMs, A New Way to Teach Programming by Dan Zingaro and Leo Porter. Dan Zingaro is an associate teaching professor at the University of Toronto, Mississauga. He has taught introductory Python programming to thousands of students over the past 15 years and has written the Python textbook that is currently being used for this course. He has also written dozens of research articles about how to teach and learn introductory CS. Dan has written 2 books with No Starch Press, the aforementioned one on Python and one on algorithms. Dan's books have been translated into multiple languages. Leo Porter is a teaching professor in the Computer Science and Engineering Department at UC San Diego. He is best known for his research on the impact of pure instruction in computing courses, the use of clicker data to predict student outcomes, and the development of the basic data structures concept inventory. He co-teaches the popular Coursera specialization, Object-Oriented Java Programming, Data Structures and Beyond, with over 300,000 enrolled learners, and the first course in the edX MicroMasters in Data Science, Python for Data Science, with over 200,000 enrolled learners. Leo is a distinguished member of the ACM and previously served as secretary of the ACM SIGSE board. Both Dan and Leo have received numerous prestigious teaching and research awards. So Dan and Leo, without further ado, take it away.
All right, let us just share our slides real quickly. We'll get started. All right, are those slides coming through okay? All right, so thank you, Michelle, and thank you for that kind introduction, and thank you to the ACM for inviting us to talk today. Also, thank you all for attending. We're really excited to be talking with you all. Dan and I are excited to talk with you all today about how large language models like ChatGPT and GitHub Copilot are likely going to change the way that we all teach programming. Certainly, LLMs have implications for education at large, and how we teach programming is not exempt. Our goal today will be to convey the motivations for changing introductory programming and our vision for teaching learners the skills they need to succeed as programmers working with an LLM. As these tools are quite new, we're also excited to talk with you today during our Q&A period. Before we start, I want to say that Dan and I have been teaching and conducting research on CS1 for over a decade. We've studied effective pedagogies, motivations for student learning, assessments of student learning, and related topics. We're leveraging that experience in this talk, but we want to be clear that we have not studied the effectiveness of LLMs in teaching programming yet. We are versed in the literature that's come out on the topic, but we haven't conducted those studies ourselves. Our experience with Copilot and ChatGPT is based on spending the past 6 months reading about these tools and working with them ourselves. What began as curiosity quickly became a clear recognition that introductory programming was bound to change. And we wanted to design courses at our schools to improve the outcomes for our students. Early on, we also recognized it's really hard to teach a course without a book to guide that course. And so we're authoring a book now that book is available in early access. So for CS1 instructors considering our approach, we're happy to provide instructor copies of that book, and we'll talk more about the book later. And we'll be teaching using this approach starting in the fall of 2023, and we'll also be studying the course's outcomes.
Thanks, Leo. What's up, everyone? As Leo mentioned, the literature on using LLMs to teach programming is just getting started. There's a lot we don't know, and we need much more research and replication studies of existing research before we can make any definitive claims. But, we're education researchers. We're going to spend some time on what companies are reporting and what the literature can currently tell us, just so we're all on the same page. It's hard to overestimate the impact that LLMs are having. I'm sure at this point you're like sick of hearing about how, the world's going to be irrevocably changed forever and ever and all that stuff. But, while we might be overestimating this in the short term, there's likely a seed of truth here. Now, for example, Satya Nadella, Microsoft CEO, is talking about the fact that software development is going to fundamentally change. And like I said, we need more research to understand claims about how much faster programmers are when they use Copilot and stuff like that. But Leo and I have already been watching software development change in ways we couldn't have predicted, even maybe 6 months ago. So similarly, Jensen Huang, that's NVIDIA president and CEO, is talking about an incredibly low programming barrier on the horizon. And yeah, well, we might not be fully there yet. If you play with Copilot on your own, just like start messing around with it, and you let your mind cast ahead a little, you might come to agree that we're not as far away as it might seem. And actually, and this was a surprise to us, the current literature kind of agrees with what these experts are saying. We're going to start with some literature about people who already know how to program. We'll transition into introductory CS1 after that. So we found this recent study from GitHub that shows that 92% of developers in the US are already using these tools. So, I mean, this is staggering, right? From 0, essentially 6 months ago, 9 months ago, to 92% today. I don't know anything else that's moved that fast in the developer realm. In addition, 70% of developers are seeing strong benefits of these tools, including, and we love this one, learning new skills, right? So it's not all about productivity, it's also about learning new skills. So if working programmers are using these tools, we likely want to help students learn to use these tools as well. In the first research paper we're going to discuss, we have a controlled experiment. So this is when you have one difference in how 2 groups work. And so that one difference can be used to determine what the difference is, given that difference between the 2 groups. Okay, so we have the treatment group. They're allowed to use Copilot, and the control group is not allowed to use Copilot. Other than that, they're allowed to do whatever they want. Okay, they can work, use the internet, they can look at documentation, all that. Only difference is one group has Copilot, other group doesn't. What we find is that the Copilot group completed the task 56% faster than the control group. And the authors also note that less experienced programmers benefited more. But okay, we have to talk about this 56% increase here. When education researchers have a 5% increase in anything, we're partying. I mean, 56% is just unheard of, okay? So I don't want to jump too early to conclusions here, but we may be looking at the possibility of a staggering productivity increase. And can you imagine if indeed people with less experience benefit more, Right, in CS, we're sadly very well aware of inequities in prior experience leading to inequities in outcomes, right? Perhaps LLMs, with lots of effort from teachers and researchers, obviously, can help rather than hurt in this regard. So in the second paper that we want to talk about, and this is what we mean that we're super early in this. So there's no 56% increase going on in this paper. So the results here are much more tempered. So we have this time is we have a within object study. That means as each participant completes 2 Python tasks. So one without Copilot, they're just using IntelliSense, which is built into VS Code. And the other group is using Copilot. And like I said, there's no difference between conditions this time on success rate. But there are still positive outcomes. So for example, the majority of participants preferred using Copilot, mostly because it provides a useful starting point. I mean, we've all been there. We're working on a new program and it's a blank screen and we're just like, what are we supposed to do? How do we get started? And you don't have that problem with Copilot. It just gives you stuff, right? Half the participants, though, did have trouble fixing the Copilot code. So for all the teachers in the audience, don't worry, this is just a small preview of what's to come in our talk today. We have a lot of skills that we still need to teach our students. Okay, we're not just done. All right, so we're going to move on to the immediate impacts of generative AI on CS1 now. So the introductory level course that people take when they want to learn how to become computer scientists. All right, so the first paper that we're going to talk about makes it clear that we need to rethink our take-home assessments. So for decades now, many of us have used small take-home assignments, coding questions, to give students focused practice on particular features of programming languages. And yeah, like we've always had to worry about students like looking up answers online and stuff like that, contract cheating. But in our opinion, now using these exercises is completely game over with Copilot in the mix, okay? So Copilot solves half of these exercises in one shot, okay, just paste the exercise and boom, done. In other cases, the authors needed to improve the prompt a little bit, but when they did that, Copilot could solve it. Okay, that's called prompt engineering. It's when you like mess around with the prompt for purposes of making the response from the LLM better. But anyway, the takeaway is if you do some minor prompt engineering, then 80% of the assignments are solved just using the LLM to write the code. The next paper is a similar game over in terms of exams. So in this paper, we're seeing kind of similar thing. Codex, that's the LLM that underlies Copilot. So Codex just solves them, right? So we cannot use these as take-home exams anymore, or online exams, or like really any unsupervised kind of exam anymore. Right, so it's clear that something needs to change now in CS1, and so the question is what? So researchers have interviewed instructors, and right now everyone's just panicking about students cheating, right? That's all everyone talks about right now. But in the long term, there are 2 main approaches for what to do. So first is resist these tools, and second is embrace these tools. Let's start with resist. So one argument for banning the tools is so that we can stay focused on perceived programming fundamentals, which may help students like build mental models and have a idea of how the computer is running their programs. So some instructors are using local libraries with like thousands of lines of code and cultural context to try to stay ahead of the AI, right, or confuse the AI, or use other types of assessments like oral or video assessments, or things that the AI presumably cannot do. But it probably goes without saying, I probably don't have to say it to this group in particular, but with the current pace that AI is moving, we're not sure that trying to confuse the AI is a viable path. And also think about how could we possibly confuse the AI and not confuse students at the same time. The arguments for embracing the tools are to prepare students for future jobs and to be able to teach more advanced stuff early on. These instructors are excited about using AI to give personalized help to students. Anybody who's taught a large class knows how time-consuming and generally impossible doing that is, and helping with time-consuming tasks like generating exercises and reviewing student code, stuff like that. So Leo and I are obviously on the embrace the tools side of things, and there are important concerns that need to be addressed. such as equitable access to the tools and biases and training data. But one positive thing we're already seeing is LLMs are forcing us to reimagine our pedagogy, right? Reimagine how we teach, and we love what instructors are doing here. Leo and I also are not convinced that we need to choose between fundamentals and preparing students for jobs. We think that both are possible, and we're going to discuss this plan later in our talk. But first, there's some encouraging new research evidence that we wanted to talk about. Right, so that evidence comes from a recent controlled study, and we're going to spend more time on this than you probably imagined we would. And the reason is we think that this is a particularly important study. So the participants in this research were young novices with no prior Python programming experience. And the participants were first introduced to some fundamentals of programming and computational thinking. And then they were asked to complete 45 tasks in Python. So these tasks were two-parters. Okay, so they started with code authoring, which is writing code from scratch. And then there was a code modification task, which is changing existing code to meet some new goal. So as you might expect by this point, one of the groups had access to Codex during the code authoring parts, and the other group didn't. Importantly, no one had access to Codex during the code modification parts. Okay, they had to make the changes to the code with no AI help. All right, so for the code authoring, right, writing code from scratch, the Codex group kicked butt. And you might not be surprised to hear that, right? There's statistically and practically significant results here, but it's like, well, sure, we already talked about the fact that LLMs do like really well on CS1 problems, so big surprise, right? You might argue though that the Codex group would suffer later when we take Codex away and ask them to modify code. The Codex group just got the code like handed to them, right? Whereas the other group, the group without Codex, wrote the code themselves. So certainly they'd be better at modifying the code later, right? Right. Well, that's actually not what the researchers found. In fact, and this is obviously super motivating for us as teachers, the Codex group still did better. Okay, so it's not statistically significant anymore, but they still did better on the code modification parts. That Codex group also felt more eager to learn programming and felt less stressed, less discouraged, less irritated while completing the tasks. In case you're worried that this appears to be some very short-living increase, it's actually not. So 1 week later, they did a post-test retention, and they still found better, but again, not significantly better, but still better results for the Codex groups on code authoring and code modification. And critically, there's no Codex going on here, right? Codex was not available at all this time. One hypothesis for these results is that students in the Codex group were immediately interacting with code, right? Just messing around with live code rather than having to struggle through like syntax errors and syntax problems first. The researchers also observed participants in the Codex group testing the code. So like to all my CS1 instructors out there, when's the last time you saw students test their code, right? Or when's the last time you saw them like breaking a big function into small functions? My answer is like, they never do that. But here they are. They seem to do this naturally. They seem to have, I don't know, some sort of built-in distrust for code that's generated by AI. And we need all students to have this. Okay, so that's the evidence right now. So Copilot's being used by programmers and it helps them. Copilot necessitates changes to CS1 and students are able to effectively learn with Copilot. Leo's going to talk all about our proposed CS1 with Copilot in a bit. But before that, I just wanted to say, we also have an opportunity here to take a fresh look at other longstanding concerns in the CS education community. I'm going to keep this brief. There's obviously way more that could be said, but we need to have these at the front of our mind as we make these large changes to CS1. All right, first let's talk about the gap between what's taught in CS courses and the needs of industry. Many authors over the years have discussed this gap. So for example, there's a study from Michelle Craig and her co-authors. They interviewed some early career programmers and they report, for example, that assignments in school are very well-defined versus the kinds of open-ended, ill-defined projects that they do in industry. or maybe writing small standalone stuff in school compared to like adding features to large existing programs in industry. We've also found in our own research that faculty want to help. Okay, they want to improve their curriculum, but there are resource barriers. So it's worth thinking about how LLMs might be able to lessen this gap. We've already talked about programmers just using LLMs in industry, so that's one way we're going to get closer. But we seem to be at the end of the road for well-defined, super constrained assignments anyway. And maybe, for example, our students could use LLMs to support them as they grapple with an overwhelming new code base. All right, beyond gaps to industry, it's not clear that our students are learning what we like them to learn. So there's a famous problem from the CS education literature. It's called the rainfall problem. And it's all about taking amounts of rainfall. Those are just integers. So integers from the input and just computing the average. And you stop when you receive a flag value like -1 or 999 or whatever. So generally what we find after a CS1 is something like half of students get this code wrong. That's at the end of a CS1. We should all be disappointed by this. It's been hypothesized that part of the problem is a mismatch between the looping constructs that programming languages have, like while loops, and the ways that people think about loops. More broadly, we've had high failure rates in CS courses for decades, and the situation does not appear to be improving. These students who are struggling are also having emotional tolls on the assignments that they do work on. So if syntax and constructs of a programming language are at least partially to blame here, what's going to happen when we reduce the focus on these through the use of LLMs? This right here, this research possibility is what excites me and Leo the most about this new technology.
Thank you, Dan. At this point, we hope you all agree that professionals are using these tools and that students may be able to benefit from learning using them. As Dan said, LLMs may be the catalyst that we need to help address longstanding issues with CS1 outcomes and the academia industry gap. But before we dive into our vision for teaching CS1, let me give you a brief demo of how students might interact with the LLMs, particularly for those of you who haven't started playing with them yet. So let's take a quick look at Copilot tackling a problem from Dan's class last year. Let's take a look at the question. Trainees here are given an ID code which has 5 digits, and the first digit can be any digit, but all subsequent digits you have to be either 1 digit greater or 1 digit less than the previous digit. Now for the assignment, students have to write code to validate an ID and cannot use loops or lists. So let's see how Copilot does with it and then discuss. So here's my interacting with the Copilot chat feature. And what I've done is I've just copy pasted Dan's description straight from his assignment and just place it straight into the interface. And you can see there's a little bit more than I showed in that last slide. We also have some sample inputs and some sample outputs. And then what we're going to do is just ask Copilot for an answer. And what it does is it gives back the pseudocode for the problem. So if we want to use the pseudocode, it's right there. And then it gives us the code for a solution. And if you take a look at the code briefly, you're going to see that it seems like it's on the right page. If we take a look at the code a little bit more deeply, we realize this is in fact a working solution. So we specifically gave Copilot Chat a new problem from Dan's most recent course because that wouldn't be in the training set, right? This is, Dan just taught this course last fall. We also searched GitHub to see if there are any examples of his code there. And yet, despite it not being in the training set, Copilot's solving it cleanly. Let's look at another example. But before we do that, let me just say what we've seen is that when Copilot works well, we effectively have a new interface for communicating our desires to the computer, right? And hasn't really the last 70 years of programming languages been focused on doing exactly this, trying to find new ways for us to communicate with the computer so it isn't quite so hard. If it weren't for this chain of advancement in programming languages, we'd all still be programming in assembly. And I want to point out that we notably, as instructors of CS1, have chosen to not teach students in assembly anymore and to teach them Python. And so what we've already decided is that ease of programming is important for new learners. We can also see that Copilot is producing code that's syntactically correct. Now, in our experience with Copilot, we rarely experience syntax errors, and we can only imagine that LLMs are going to improve in this regard. And so at the very least, working with these tools may mean less emphasis on having to teach syntax. Now, if every user prompt unambiguously described the problem, and Copilot were always able to generate the correct code that meets the prompt specifications, we could really just end the talk here and frankly be a lot more worried about our jobs and about software engineering jobs in general. But we all know LLMs make mistakes, and humans may, just maybe, struggle writing perfect specifications. So let's take another example from Dan's class last fall. Here he's asking students to take sentences of the form, and this is the second example. Ilana eats apples, oranges, kiwis, and bananas. So the expectation is that there are two words, Ilana eats, then there's a list of nouns, the word and then a final noun. And the goal is to ensure that there's one comma after each noun, and yes, we want to include an Oxford comma. In the first example, we see that the original sentence is missing the commas, and the expected output will add the commas. In the second example, there's already a comma after the word oranges. So that comma is going to be preserved, but the missing commas will be added. What makes this tricky for students and possibly tricky for Copilot is that students aren't allowed to use if statements or for loops to solve this. Instead, they have to use just the replace method. Now let's take a look at the full description of this. So here's the actual full problem description. Don't worry about reading it, but what we're going to do is, just like a student might, perhaps without reading entirely, is we're going to just take the assignment, copy it, and put it into Copilot and let Copilot solve it. So here's us doing that. So I've pasted in that full description. And there's a little bit more to the description than I showed. There's some additional sample inputs and sample outputs. And then when I ran this, it actually took longer for Copilot to give me the answer than I'm showing here. We actually trimmed that as part of the video out there. And when we get back from Copilot, seems fairly plausible in our first glance, right? There's no conditionals, there's no loops, and it's also using the replace method. But if we look at this code a bit more in depth, we can tell pretty quickly that this may not work well. First, we could just run one of our sample inputs and find out that it seems to add commas where they don't belong, and it seems to even cause duplicate commas. Or we could have looked at this line of code here and seen that it puts a comma before the word and, whether or not it needs to. Or we could have looked at this line of code and we'd see that it's replacing spaces with comma spaces, which will add more commas than we need, again, ignoring what was there before. So in this case, Copilot didn't give students the right answer on their first attempt, and they're going to need to learn how to work with these tools in order to get the right answer. So in sum, what we're seeing is that users of LLMs, including students who will be learning how to code working with them, will need important software engineering skills like code testing and code reading. And that segues us to the skills needed to program using LLMs. So we're going to present our vision for a CS1 course that's fully incorporating LLMs and teaches students how to effectively write software using Copilot. In our discussion, I'll be focused on the skills that we need to teach our students. Our vision is informed by our work with Copilot and will be how I teach my course this upcoming fall. We'll know more about its effectiveness as we study it further. But in the meantime, we're excited to share our vision with instructors who may be interested in teaching courses this way this fall and may be interested in collaborating on course design. All right, so at a high level, we want to talk you through the design cycle of writing software working with Copilot. And this is the design cycle that we've uncovered working with Copilot a great deal over the last 6 months. Now, let's assume we want to solve a task. At this point, let's assume that we have a task that can be solved as a function. Well, we'd start by describing the function and then using that description as a prompt. Copilot will then generate code based on that prompt. We'll then get code back and read through that code to see if it seems to be a reasonable solution. If it's not, then we can use the Copilot feature to help explore other suggested solutions and select one which may be better at solving the task. If we still can't find a plausible solution, we have to go back to the prompt to see if we can better describe the problem. Supposing we find code that we like, we can then progress to testing the code. If the code passes our tests, well, we're done with this function. If it doesn't pass these tests, then we have to either go back to the prompt to see if we can have it better describe the failed tests, or we can go back through the process of finding the bug and where the bug is in the code and correcting that bug, either by modifying the code directly ourselves or by prompting Copilot to generate new code. So everything I've shown here so far is the flow of trying to solve a single task. And we're, again, focused on functions as the primary task in our workflow. But we can't just give a huge problem to Copilot to solve as a single task. Instead, if we're giving a problem that's too large for a single function, then we're going to have to break that down through problem decomposition. And once we've broken that down into solvable tasks, then we can start designing our functions from the leaf functions on up. We also want to note that problem decomposition is a valuable tool in the function design cycle as well. If you can't get a good piece of code based on a prompt, it's often a time to do problem decomposition and break that into multiple functions. Now, there's a lot involved in the steps of this process that I just described. So what I'd like to do is just talk about the skills that students need to perform these steps. All right, so the first skill is function design and prompting. So students need to know how to articulate a task by describing its behavior. For functions, we found that Copilot gives better answers when we provide the function signature, which means that students need to know how to briefly describe the function, its expected inputs, and its expected output. Then we need to be able to describe the function's behavior as precisely and as briefly as we can. And we found Copilot does better when we write these as doc strings rather than as comments. And so this is an example of a function along with its corresponding doc string. Once students, and the next skill is code reading and selection. So once students have the suggested code from Copilot, and you can see here, this is the code that Copilot gave us for that prompt. Students will need the skill of reading in order to determine if the suggested code is doing what they want. If the code does not seem to meet their needs, they're going to need to be able to read through a number of suggested code options from Copilot to determine which may work. And if none work, they'll have to return to prompting or possibly even more problem decomposition. Now, in this case, Copilot gave us a reasonable answer as the first suggestion, and so we'd move over to testing. But if it hadn't, I might move on to suggestions like these on the right. Now, in VS Code, you can see these suggestions just by pressing Control-Enter. Notably, the second suggestion here seems pretty plausible, and it's actually pretty close to correct. So I could imagine students thinking this answer, the second suggestion here, is correct. In which case, if they were to select that, they'd have to catch the bug in it during testing. After they have the plausible solution in hand, the next skill is code testing. Students will need to be able to author tests and to ensure that the code has the correct functionality. This will also require that they be able to read and understand the code so they know what tests to run. Right? They need to be taught how to do open and closed box testing, and they'll also need to learn how to write tests for the common case as well as edge cases. It'll be good to teach them multiple ways to test, and we're partial to doc test. In the code on the right, we've added a couple of test cases for doc test, both of which pass on this suggestion from Copilot. All right, the next step is debugging. And so if they're stuck with their prompts and they've decomposed the problem as much as they possibly think they can, they'll need to turn over to debugging. And here's where we would have students using the VS Code debugger, just running on that segment of code. Students will need to be able to be taught how to add breakpoints, how to monitor the state of variables, and essentially just how to use a debugger to understand what's happening as the code executes. Now, this is our code running on a test case of an array with 4, -2, and 1 in the array, and we're the second update to min inside the loop. In the debugger, we can see that min is currently 4 and num is 1, and so min is just about to be updated to the correct answer of 1. Beyond learning how to debug, teaching students how to interact with the debugger and follow the state of variables during execution can help students develop machine models for execution and help them better understand how their code works. Now, notably, this is a skill that we haven't taught explicitly in our existing CS1 courses, and at least anecdotally talking to other faculty, they tend to not teach debugging as an explicit skill either. And so we're quite excited about teaching this in detail in our upcoming course. The next skill is problem decomposition. And so students need to be able to take a large task and break this into smaller pieces. Their goal is to create a design where each function is solvable by Copilot. So the example here is decomposing the task of creating a basic video game into smaller functions, each of which was then solved by Copilot with just a little bit of assistance. We suspect problem decomposition is going to be a challenging task for students, but it's actually one of the most important skills, I'd argue, to know as a programmer. And so for students to develop the skill, we'll need to scaffold students in a number of really important ways. They'll need to be able to learn what's a reasonable task for Copilot, which means they'll need to be given plenty of tasks that are of the correct size, and examples of how to recognize when a task needs to be broken down into subtasks. They'll also need to see examples of instructors breaking down problems along with descriptions of why the instructors are making the choices that they're making to help students get insight into the actual process of problem decomposition. Now, similar to testing, we think problem decomposition isn't commonly taught in CS1. And this is because use of autograders, which is really common in lots of large classes at schools, including my own, that use of autograders makes it so instructors do the problem decomposition for the students and so that they can grade for partial credit. And so we're really excited to be teaching students this skill in the new course design. The last skill is identifying useful modules. And we haven't talked about this skill yet, but often part of good design of software in Python is determining if there are modules that could help you solve the task. We found that Copilot actually does better at generating correct code, when it's told which module to use. And conveniently, Copilot Chat is actually quite good at identifying which modules might be the most helpful. Here's an example of my asking Copilot Chat which library would be good to use for adding a watermark to an image, and it reasonably suggests using Pillow. Beyond identifying possible modules to help Copilot, it can also give students the pros and cons of using each module and whether each module can require installation. I've actually been really impressed by Copilot Chat when I've had conversations with it about which modules to use. We want to mention this skill specifically because knowing what modules to use for a particular task can help broaden the range of problems solved by students. In a traditional CS1, we may only teach students a few modules, and although they may become comfortable working with those modules, I've seen students really struggle if asked to use a module that they're unfamiliar with. And we believe that teaching module selection explicitly will help students be able to solve new problems both in the course and after our course is over. So I want to do a quick aside on assessment. We've talked a lot about how traditional CS assignments, particularly those that are set for auto grading, again, that are used really commonly at large schools, including my own, are going to be really heavily impacted by Copilot. And the question just becomes, well, what do we do instead? Well, I think assessments are going to need to change. And here are some of the ideas that we have and that we could explore when we're designing these new assessments. Now, one option could be giving students more open-ended tasks. These assignments will allow students to be creative in their solutions, which could help engage more students and avoid issues with academic integrity. An example of a creative task would be creating image collages, like those commonly done today in courses using Barb Erickson and Mark Grisdale's media computation curriculum. On the right is such an assignment done by students in one of my courses. Another idea that we like comes from Laurie Jacques in ACM Inroads last month. She argues that we could have students create different representations of the same concepts, just as they do in math education. And I'd encourage you to take a look at her article. I think there's a lot that we could do as instructors with this idea. For example, we could have students create flowcharts that capture the behavior of a particular piece of code as an alternative representation than the code itself. A third example is to use the computer-based testing facilities like they have set up at the University of Illinois Urbana-Champaign. These test facilities have computers running controlled environments to help ensure academic integrity. Now, many of the faculty using those testing facilities at UIUC are also using a tool called Prairie Learn, which I believe is being augmented right now to allow students to use Copilot for some questions, and the instructor can essentially say which questions the student should have Copilot access to or not. The setup at UIUC already gives students the ability to get more practice and to take more frequent exams, which is just generally good for students overall, right? But for our purposes, it would allow us to specify parts of the exam where the students don't have access to Copilot and other parts of the exam where students would in fact have access to Copilot. And so you could give a semi-large open-ended task and have students solve it during the exam with Copilot as an aid.
All right, thanks, Leo. So just to summarize, here are all the skills that we're excited to be teaching in our upcoming version of CS1. And we think most instructors would be excited about teaching these skills. In our experience, testing, decomposition, they're generally not taught much in CS1. And this absence limits the ability of students to take on large problems. Moreover, explicitly teaching students how to find and use new modules can broaden the range of problems that they can solve after they finish the course. So rather than spending an entire term teaching students how to write single functions with, maybe like half of students not being able to write a function like rainfall, which is seriously not a good outcome for CS1, we believe a CS1 with Copilot will result in students being able to solve larger programming tasks in a broader range of domains, and this will make them more capable of writing software. So LLMs certainly introduce new opportunities, as we've spent the past 40 minutes saying, but there are some new challenges, and I'd like to mention a few of these. This is by no means exhaustive. The first one I want to mention is we've been focused on CS1 here, but we don't think this is the only course that will be impacted by LLMs. So for example, think about a data structures course, right? We often have students implementing stuff from scratch, like linked lists, binary search trees, things like that. If those are take-home assignments, then you've probably assumed, and this would be correct, that Copilot is just going to solve these very well. So we're not going to be able to use those anymore. The second concern is monetary. So right now, Copilot and similar tools are free for students, but what's going to happen if they start charging? Things are going to get tricky in that case. So we could consider going back to just banning the use of these tools. But if we do that, then the students who have money are just going to buy them and use them anyway. And so we'll have a serious equity problem. Alternately, if we mandate use for all students, we need to figure out who's going to pay for this. The third challenge is ethical. Well, we've likely all seen the discussions in the media about concerns around code ownership and bias in the models. We share the argument made by Tyson Kendon, Leanne Wu, and John Aycock at WIXI earlier this year. If students are going to be using these tools, we should be teaching key ethical concerns to them. And ultimately, we need to remember that students will use these tools, period, right? They'll use them whether we say they can or they can't.
This fall, we're going to be teaching a class based on this approach at UC San Diego and are happy to share or collaborate on course materials over the summer. The book to support the course is in early access through our publisher, Manning Publications. Right now, the first 4 chapters are available, and we foresee more chapters being released at a fairly quick pace over the next couple months, so that the full book is available electronically before the fall term starts. I'm going to be using the book for my course, so it will be ready in time for my term, at least electronically. We also have an aspirational goal of having physical print copies being available by September, but that's going to depend on a lot of factors, and so we're hesitant to promise that. If you are a CS1 instructor and want a copy of the book to review before the fall, please just email me to get an instructor copy. I'm happy to share it. And my email is at the bottom of this page. I'll be bottom on the next slide as well. We'd like to thank the many colleagues that we have at University of Toronto, University of California, San Diego, and University of Illinois, Urbana-Champaign, who've been helpful in designing our in the design of the book, as well as our upcoming course this next fall. And with that, we'd like to take your questions and are open for discussion. Thank you.
Great, thank you, Leo and Dan. That's awesome. So we have more than 50 questions and about 12 minutes. So I've been trying to take the question. I haven't even looked at the chat because I can't keep up with both and hear the talk, but I've been trying to take the questions out of the question and answer and group them into some topics so that we can have one question from each area. So a couple of people, let's start with let's start with a question about pedagogy and learning goals, or maybe it's not learning goals, but so Edmund asks, presumably the students will have to have some understanding of programming to evaluate Copilot's solution. So do you have to teach programming first before use of Copilot?
Yeah, do you want this one or do you want me to take it?
I'd be happy to. So Leo and I agree. So it's not, so to us, this is not just, put the problem in, get the answer out and game over, right? So for example, in our book, we spend 2 chapters on reading code, and we definitely think that's necessary, right? So you're gonna get code back, and you're gonna want to be able to, I mean, if the code doesn't work, you're gonna want to be able to fix it for sure. But also, we think there's value in just being able to get an overview of what the code is doing, right? Does it look, so we talk about a lot in the book about, does the code look reasonable? And part of knowing whether code's reasonable, like experts do this, right? They are, they're experts partially because they can look at code and be like, you know what, nah, this is bad, right? And you're not going to catch every bug like this, right? But Leo and I and everybody else here can do that. And so we want our students to still be able to do this, right? So code reading is a big focus that we have. We totally agree.
Great, so staying on the curriculum theme, Yang asks, the new vision may seem like a new class instead of a revision of CS1. Knowing how to use AI to write code in a more efficient way may still need the understanding of the code itself. Would it be ultimately a separate course or workshop that teaches people who already can write decent code, for example, past CS1, to write code more efficiently? Or can it be organically plugged into the current CS1 curriculum? So I'm guessing Yang hasn't yet looked at an instructor copy of your book, but maybe you could at least address that question. Probably that's shared by, some other number of the 1,600 people watching our talk.
So I think that's like a fantastic question. Where this fits in the curriculum isn't entirely clear to us, but I do want to say, if we look at the learning goals, and let me jump to those. I've actually got those here available. If we kind of run through the learning goals, these are based on Bloom's taxonomy. This is knowledge level, comprehension level, application level. What we're seeing are things like being able to work with loops and functions and dictionaries and modules in Python. We would also have at the next level of Bloom's taxonomy, we've got designing tests, fixing bugs in Python code, being able to write complete and correct Python code using a top-down design. These feel to me similar enough to CS1 that I'd argue this is a good replacement for a CS1, but I think it's not just CS1 that's going to end up changing because of these tools. And so I think a lot of our curriculum may be changed, and it's unclear to me at this point how everything's going to shake out.
Okay, great. There's a number of questions about assessment. I'm not sure that I got the best one out of them, but maybe you could just address assessment. So the simplest question was Arno, who asked, how does assessment look like in this new model? And there were a number of other variations of that.
Leo.
Oh,
Sure,
and in
yeah.
particular, someone asked about how we do assessment with really large numbers of students. So if you have a course with 800 or 1,000, not an assessment in a small class where we can imagine what you might do.
I think that's a great question. Assessment's been at the forefront of our mind. Obviously, we've designed assessments and research and stuff, so this is core to us. I think there are a lot of factors at play. I think I want students still to be writing code, and I want them to be solving large assignments, but I really do believe in open-ended assignments. And this is going to be tricky for large classes because we've been able to use autograders for a long time, and I'm not sure if autograders are still going to be a good fit for some of these large assignments. And so I'm encouraged by some of the interesting work some of my colleagues at UCSD have done, where they have students record videos of them walking through the code for their assignment, and those videos are what's recorded. So I could see doing that. I'm personally really excited about the computer-based testing facilities that are at UAUC. Craig Zullis gave a talk at UCSD recently, and I think we're really planning to adopt it this fall. And the advantage of those testing facilities is that we can write lots and lots of questions with randomization, and then the students can do these as homework. I think a lot of questions will actually be classic written questions of trace this code, or what's the state of the code at this point in time, or given this code, how would you explain in a short sentence, like explain in plain English? I think there's a lot of questions that we can still leverage from our previous versions on homeworks and things like that. For tests, though, I'm really excited about these test-based facilities because I would like some portion of the exam to be without Copilot, right? Having them explain what the code does, things like that. I want them to be able to do that without Copilot at times. And then in other parts of the exam, I want to just give them a large task and say, use Copilot just as the flow through the class has been, and solve this larger task. I think that's going to be really valuable, having these test facilities, especially in large classes. Is there anything you want to add to that, Dan? Or does that summarize things well?
Yeah, so I just noticed somebody in the chat said we need a whole new webinar for assessments, and I pretty much agree. So we can leave it there for now.
Okay, great. So there's been a couple of questions about curriculum. What other things could fit in the curriculum? So Jane asked, do the presenters see a place in any new CS1 with data-driven programming paradigms for social and ethical considerations? And also asks, do you think that the LLMs are an opportunity to have a resurgence in requirements analysis and logical design? And actually, let's stop it there for the curriculum question. Someone else asked about prompt engineering, but we'll take that one next.
Yeah, there's a lot to say here. So the challenges brought by LLMs, political challenges, ethical challenges, it'll take some time for us as a society to catch up. And there's this talk that Leo and I like to recommend by Tyson Kendon, Leanne Wu, and John Aycock. And it was at Wixie just a couple months ago, and the paper was called AI-generated code not considered harmful. And what they argue, and we definitely recommend like watching that talk. It's totally worth it. But this is such an opportunity for us to teach ethical implications of LLMs. So do we think there's a space for this in CS1? 100% yes. Leo?
I completely agree. I mean, I think this is, I'm a huge fan of teaching ethics in the curriculum. I was an advocate for adding ethics as a learning goal to our program. And I think this is a chance for us to say, we're bringing in these tools. We know there's ethical implications of these tools. Let's talk about the ethics of these. And then once you start talking about ethics, it allows you to talk about ethics and other topics in your CS1 course.
Okay, great. And staying on the curriculum theme slightly, Jose asks, what's your view on the skills to do good prompt engineering? In the end, Copilot is a sort of programmer and we are the customers, and customers in classical software engineering often do not state well the requirements of the product, or the programmer do not understand it well. Is that an issue when using LLMs for programming?
You certainly need to understand what they're trying to solve with the function well. And that's why we're such a big fan of teaching problem decomposition early in the courses. With teaching problem decomposition, the students are going to break down the problem. They're going to have an idea what each function should do. They should have specifications for each of those functions, and then they should put those into prompts. I think the challenge, and this isn't directly what was asked, but I think one of the challenges when we were writing the book, and the challenge for us as teachers, is as experienced programmers, we tend to use a certain language about technology and software, and we feel like the prompts respond very well to that language, right? If you say, I need you to open a file in read-only mode and then do blah, 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 blah. Copilot does a great job with that. But we're going to need to teach students that similar language of describing the specifications in a technical language.
Great. Okay. So Peter asks about process. He says, are there any thoughts to the evaluation of the process instead of just the final product? For instance, mandate that students submit the prompts they used to iterate and troubleshoot their program throughout the development process.
I think that's a great idea. Thank you, Peter. We're looking for more assignments, and so you really helped. I completely agree. I think some of the test questions we were already imagining is what test cases would you write for this prompt? Like, given this prompt, what test cases should you be writing to see if the function works properly? And that's process. The prompts themselves, I think we could grade in terms of how well the problem's described. I wouldn't want to put them through Copilot and then see if the answer is right. That's one of the catches is the non-determinism makes things really hard for students. It makes it really hard for grading, and honestly made it really hard for writing the book because we just don't know. The prompt could be completely reasonable and Copilot could give you the wrong answer sometimes, and sometimes they'll give you the right answer. And so it wouldn't be auto-graded, but we could certainly manually grade those prompts and say, yeah, that seems like a reasonable way of describing the problem. I love the idea. Thank you, Peter.
Yeah, critical skills too, right, Leo? Like just working through the process of, okay, I put a prompt in, I'm not getting a good result back. Now what do I do next, right? This whole like back and forth with the LLM, it would be amazing to be able to capture that process data. It actually sounds like something that would be fun to grade, which is kind of weird for me to say.
Yeah, and we have these diagrams, like this process diagram that I have here. Those diagrams are in the book. We're actually teaching process the whole way through.
Mm-hmm.
Excellent. Greg asks, will the use of LLMs further marginalize students for whom English is not a first or a strong language?
It's a really good question.
Yeah.
I think it's a challenge that's been faced by students in existing CS1s already because of code being in English. There's some really good work by Gerald Susai-Raj on non-native English speakers and learning how to program. I don't know if people have looked at how well these tools respond to non-English, and I haven't played with that myself. So I don't feel like I can give an informed answer on that.
Yeah, there's also a similar concern about bias in training data. So one of our concerns is it has less context for projects that may be of interest, that may be culturally relevant to certain populations over others. So there's obviously work to do there.
Okay, we have time for one more question. So I just thought I'd give you a real doozy. So it's been asked twice by T. Harris and Mark Friedman, both said sort of the same thing. I'll read the shorter one. Even if CS1 Intro to Programming still exists, say 5 years from now, what should it look like based on Copilot, not of 2023, but of 2028?
If Copilot of 2028 is able to take a vague human description and always give the human back what they want, I don't know what CS looks like at that point. It's going to be a completely different world. I think the LLMs are going to keep making mistakes. I think the mistakes are going to get narrowed though. And this process that we're describing, it will adapt, I think, fairly well as the tools get better.
Great. Well, we're out of time for today. I'd like to thank Dan and Leo again for their informative presentation and insightful answers to the 15 out of 70 questions that we actually got to. A special thanks to each of you for taking the time to attend and to participate today. This talk was recorded and will be available online in a few days at learning.acm.org. You can find announcements on upcoming talks and other ACM activities at learning.acm.org and at acm.org. Also, please fill out the quick survey where you can suggest future talks or topics or speakers, and you'll see the survey on your screen in just a moment. So on behalf of ACM, Dan Zingaro and Leo Porter and myself, Michelle Craig, thanks again for joining us, and I hope you will join us again in the future. This concludes the talk.
Thank you.
Thank you.